guys, welcome back and thanks for checking in. Well, we're plugging right along in math class and we are finally starting unit number 6, which is titled the Pythagorean Theorem. Technically this isn't supposed to be a very long unit, probably looking at wrapping this up in maybe 2 or 3 weeks. Should have this unit done before spring break if everything goes as planned. So, your learning target for this first lesson is that you will be able to use the Pythagorean Theorem to identify right triangles and to find the missing side length of a triangle. Okay, so here's some information about the Pythagorean Theorem. We need to first discuss a right triangle because the Pythagorean Theorem only applies to right triangles. So just for the sake of review, a right triangle is a three-sided polygon. Yes, that makes it a triangle. That has one 90-degree right angle, which is formed by the legs of the triangle. So then you can see in this little diagram here, I've got this nice little right triangle. And down here in the corner of this triangle, you see this little notation of the little square, and inside that square I put 90 degrees. That's just for review, right? So that when you see that little square down there in the corner of a triangle, that definitely means it's a 90-degree angle. And that 90-degree angle is formed by the two sides of this triangle that are called the legs. The legs come together there and make that 90-degree right angle. So, if the legs form the 90-degree angle, we have this other side hanging out here that does not touch that 90-degree angle. It's kind of sitting out here across from the 90-degree angle. That's called the hypotenuse. So you've got the legs that make the 90-degree angle, and then the longest side of that right triangle, which is the side that does not touch that 90-degree angle, is called the hypotenuse. All that's really good terminology, because you're going to hear me talking about legs and hypotenuse and right angles and so on and so forth. Here we go, Pythagorean Theorem. It only applies to right triangles. So if you see a triangle that isn't a right triangle, I guarantee you the Pythagorean Theorem isn't going to work. But here's what it says. The sum of the squares of the legs is equal to the square of the hypotenuse. Now, in the video, hopefully, that you watched for this class prior to watching this video, I had posted a little clip for you to watch about the Pythagorean Theorem. I think it was like a 3.5-minute video that kind of gave you a nice graphic representation of how the Pythagorean Theorem works. So you've already seen that, and of course we're going to be talking about it more in class. But the actual formula behind this is a squared plus b squared equals c squared. Now what's this a, b, and c nonsense? Well, it says the sum of the squares of the legs. That's this part right here. This means a leg squared plus the other leg squared equals the square of the hypotenuse. Hypotenuse squared. So the legs are A and B, and the hypotenuse is C. So what this means is we're going to square the value of one leg, we're going to square the value of the other leg, and when we add those together, that should equal the square of the longest side, C, also known as the hypotenuse. Okay, and then down below here you can see I've typed. As long as you know 2 of these 3 sides of this triangle, you could know any 2 sides. You could know A and B, or you could know A and C, or you could know C and B. You'll always be able to use this formula here to calculate the third missing side. So A squared plus B squared equals C squared. That's really, you're going to hear me saying that a lot. A squared plus B squared equals C squared. That is the Pythagorean Theorem, where A and B are the legs and C is the hypotenuse. And it's all mathematical. You're definitely going to need and want a calculator in this unit. Let's look at an example here. I've got this nice little right triangle. Right, I'll prove it to you. I'll put that little box down there. Okay, now we're comfortable. We know it's a right triangle. And I wrote the formula up there, a squared plus b squared equals c squared. I've labeled the a, b, and c sides of the triangle, the two legs and the hypotenuse. A has a measurement of 3 units, and B is 4 units, and C is 5 units. So if I plug these numbers in to the A and the B and the C positions, and I do the math, it should work. So let's plug it in and make sure. A squared would be 3 squared, right there. B squared would be 4 squared, right there. And C squared is the 5 right there. Now, get your calculators out, and don't you dare tell me that 3 squared is 6. It is not. 3 squared is 9. 4 squared is not 8. It is 16. And 5 squared is not 10, right? It's 25. So I'm simply squaring those numbers. And now, what is 9 plus 16? 25. Does that equal 25? Are they equal? Yup. So it works. When you square the legs and add them together, that equals the square of the hypotenuse. This is known as a 3, 4, 5 right triangle. Cool, huh? It's really not that hard of a formula. Goodness knows you've done far more difficult things than that this year. So let's see if we can use the Pythagorean theorem, a squared plus b squared equals c squared, to determine if these are right triangles, okay? So I'm looking at this first triangle here. I'll number it number 1, so you know where I'm at there. I'm over there. And I'm looking to see if this is a right triangle. Well, I need to have 2 legs and a hypotenuse. Now remember, the legs make a 90-degree angle, and the hypotenuse is the longest side of that triangle. So I'm looking here, I've got a 10, a 10, and a 7. There's no way I can even plug this into the formula because there is no hypotenuse. Remember, the hypotenuse is the longest side, and I see 2 sides that are both 10. So there's no way that this is a right triangle. Not a right triangle, no. All right, let's look at triangle number 2 over here. Okay, well, I don't know. It doesn't look like a right triangle to me, but I don't know. It could be. Let's check out the math. The legs would be 8 and 7. This would be your A and B. It doesn't really matter who's A and who's B. But definitely the longest side is 9. So I know that the longest side is C. That's the hypotenuse. Now let's see if the math works. A squared plus B squared would be C squared. A squared would be 8 squared. B squared would be 7 squared. And C squared would be 9 squared. 8 squared is 64. 7 squared is 49. We're adding those. And that's supposed to equal 9 squared, which is 81. 64 plus 49 does not equal 81. So no, not a right triangle. And it doesn't even look like a right triangle. But we just mathematically, we just proved it's not a right triangle. It does not fit the Pythagorean theorem. Look at triangle number 3 here. Remember, you have to have one side that's longer than the others. This to me looks like an equilateral triangle. All 3 sides are equal length. I can't even make this fit into the formula because there is no C. There is no longest side. So again, no way is that a right triangle. Let's look at triangle number 4. I'll put that there so everybody's a little more comfortable. No, I'm not going to put that there. I take that back. I'm giving you the answer if I put that there. Do you see a longest side? I do. That's your C. And then A and B can be either way. And let's see if this works in our formula. A squared would be 6 squared. Plus B squared, which would be 8 squared, is supposed to equal C squared, which would be 10 squared. 6 squared is not 12, it's 36. 8 squared is not 16, it is 64. And 10 squared is not 20, it is 100. 36 plus 64 is 100. And does that equal 100? Yay! We have a right triangle for sure. Now I can put that little box down there, that little notation, indicate a right triangle. We proved it mathematically. 6 squared plus 8 squared does equal 10 squared. Right triangle. Good job. Couple more slides. Now let's put this thing to work. These are right triangles. The little notations, the little squares are there for you. Let's start labeling A, B, and C. So I remember that the two sides that make that 90-degree angle are the legs. So again, this could be an A, that could be a B. It doesn't matter who's who. There's my C. I need to find that missing side length. I'm going to write the formula up here so that I don't forget it. Remember, C is the longest side. In this case, C is the one we don't know. So let's plug into our formula. For A, we have 3, so it's 3 squared. For B, we have 7, so it's 7 squared. And that should equal C squared, and that's the one we don't know. 3 squared is 9. 7 squared is 49. And C squared, we don't know. 9 plus 49 is 58, equals something to the second power. Now, let me show you what to do in this case. When you're trying to figure out some number to the second power squared, right? C squared is equal to 58, and you need to know what C is, like you need to undo this or do the opposite of squaring a number, is taking the square root of it. So we have to find the square root of 58, and that will tell us what C is. So on your calculator, make sure you're able to use the square root function, and you're going to end up with a decimal, and that's okay because the directions tell us to round to the nearest tenth. The square root of 58 ends up being 7.6. So that is our missing measurement there. And does that in fact become then the longest side? We've got a 3, a 7, and a 7.6. Yep, that works. Let's do another. I see the legs there because they make the 90-degree angle. So I'm going to say A and B just to remind myself that that's A and B. And C again is the longest side, and here it is, the one I don't know. So it's 2 squared plus 6 squared equals the hypotenuse squared. 2 squared is 4. 6 squared is 36. And C squared, I do not know. 4 plus 36 is 40. Equals some number to the second power. How do I find that number? I take the square root of 40 on my calculator, and that will tell me what C is. Square root of 40, if you round to the nearest tenth, ends up being 6.3. If I put 6.3 there, is it in fact the longest side? It is. Chances are my math is correct. These are our last two examples, and then we're done. Let's label our sides A, B, and C. I know the legs make the 90 degrees. So there's A, there's B. And C is over here, right? It's the hypotenuse. Formula. What's A? We decided it was 6, which we have to square. What's B? This time we don't know, but we're going to square it. And what's C? 10, which we're going to square. 6 squared is 36. B, I still don't know. And 10 squared is 100. Trying to find out what B is. So you need to move that 36 to the other side using subtraction, right? Here come our nice little algebra skills. So now I've got B squared. 100 minus 36 is 64. If I want to know what B is, I have to take the square root of 64. Calculator. It's 8. So if I make B have a value of 8, is C still the longest side? Yes, it is. So I'm probably right. In fact, I know I'm right because we worked with this triangle earlier today. This is a 6, 8, 10 triangle, much like a 3, 4, 5. Last one, decimals. Boy, they just love to always dial it up a notch, don't they? Come on, you can do it. Last one. Get your calculator ready. Let's label our sides A, B, and C. The legs are A and B. The legs make that 90-degree angle. There's my A. Here's my B. C out here, longest side, not touching the right angle in any way. One more time. What's A? I don't know. What's B? 5.3, which I'm going to square. C? 7.2, which I'm going to square. A squared, I don't know. 5.3 times 5.3, look at this. That's that. 7.2 times 7.2. All done on a calculator. When you try to solve for A, you got to get that 28.09 over to the other side. Come on. You know what to do. Subtract that from both sides. It goes away there. I'm left with my A squared that I'm still trying to find. 51.84 minus 28.09 leaves you with 23.75. So whatever A is to the second power equals 23.75. So that means that if I want to know what A is, I have to take the square root of that number. And would you believe the square root of that is 4.9. So if A is 4.9, does that still leave C as the longest side? Yep. Good job. Lots going on here. But, you know, we're going to baby step our way through this over the next few days of class. You know, I would say probably the next 3 days. We'll just be working with the Pythagorean Theorem over and over and over and over and over again until it sinks in. All right? So, welcome to Unit 6. All right, I'll see you in class.